Okay, so welcome to our latest unit where we're going to be looking at chemical reactions, and we're going to start talking about endothermic and exothermic. A lot of you have covered this content before, so you're feeling pretty confident with it. So feel free to skip through and just take notes on the bits that you're unsure of, maybe the energy level diagrams. If you want to review it, then stick with me and we'll go through it bit by bit. So hopefully you remember the idea of chemical reactions, the idea that when we have a chemical reaction, we start with reactants and they're always on the left-hand side, and then we use an arrow to show that a change occurs and we end up with products. At this stage, we tend to say that chemical reactions are reversible, so we can look at different examples of them like cooking an egg or baking a cake, where the ingredients undergo a chemical reaction and they turn into something new. Okay, so we do need to be comfortable with using chemical equations to represent a chemical reaction and how to balance these. If you're uncertain of these, then I will give you a link to a couple of other videos that you can watch and have a bit more practice. But these are skills that we should have already moving forward. If you need a hand with them, make sure to make time with me to get a hand. So along with chemical reactions, we've also looked at the things that indicate a chemical reaction is occurring if we look at something. Okay, so we don't get a heads-up display telling us that a chemical reaction is occurring, but we can observe a number of different changes that let us know that one has happened. These are a permanent color change, the production of a strong odor or the smell changing, the formation of a precipitate. Remember, this is when two solutions are mixed. Okay, so there's no particulate visible and a solid forms. Okay, so this means if I mix two clear and colorless solutions or two clear solutions and I see the formation of a powder or it becomes cloudy, we get the formation of a precipitate. Gas production, which we will see in the form of bubbles being formed. Then a temperature change, this can either be temperature up or temperature down. The formation of light, and as I said before, a permanent color change. So these are all the different things that indicate the chemical reaction has occurred, and again are things that we should be pretty comfortable knowing already. Generally, what's happening when these chemical reactions occur is that we're seeing energy transformations. Okay, so you may remember that energy is conserved. We can't make or destroy energy. All we can do is transform it into different forms. So all chemical reactions involve a transformation of energy. The molecules and compounds have chemical potential energy, and then when the reaction occurs, the products will have a different amount of potential energy. So some of that difference in energy is changed into kinetic energy or heat or light. Okay. So this goes a little bit further than what you may have seen before in Year 9, and this idea that in exothermic reactions and endothermic reactions, we can look at these in terms of what's going on with the bonds in the molecules and the compounds. Okay, so in a chemical reaction, energy is always used to break bonds. Okay, so we always have to put energy in to break bonds. Okay, and that makes sense. If you think about if you want to try and break something or snap something, you've got to exert effort. And the same goes for a chemical bond. So in order to break the bonds in the reactants and convert them through to the products, we need to put in energy. The more energy is used to break the bonds than is released, then it's endothermic. So if I put in more energy to break the bonds than I get back out, because making bonds gives energy out. Okay, so energy out when we make bonds. If I put more in to break them than I get back out, the reaction will be endothermic. If I put in less than I get back out, the reaction will be exothermic. Okay, and exothermic is energy out into the surroundings, okay, into the environment. And then endothermic is energy in from our environment. Okay, so we've got to remember where the energy is flowing from and to. So looking closely at exothermic and endothermic, it really is a matter of knowing what our surroundings are and what our system is. Okay, so if we think about the system is reaction itself that is occurring, okay, but then the surroundings is everything other than that reaction. Same with exothermic. So if I have a reaction that is occurring in solution, then the system is the reaction itself, okay? So this is the molecules and particles that are actually undergoing the chemical reaction, okay? But everything else, so the solvent that those things are dissolved into, is my surroundings. So in this case, that means that for an exothermic reaction, the system will release energy for an exothermic. Okay, so the solvent will go up in temperature because it's going to absorb that energy. Okay, for an endothermic, it goes the other way. For an endothermic, the system will absorb energy. So the temperature of the water that those things are dissolved into will actually go down. So a reaction being exothermic or endothermic will cause a change in temperature. So we can monitor this experimentally. When I mix an acid and a base together, okay, usually I will have a clear and colorless solution that looks like water as my acid and a clear and colorless solution that looks like water as my base, and when I mix them together it still looks clear and colorless and white like water. But the temperature will increase. So while I won't be able to see if a chemical reaction has occurred, I can measure the change in temperature and know that it has. So this brings us to the key factors of exothermic reactions. They will always give out heat or light, or sometimes both, because this is a transformation of energy. Okay, so the temperature will increase or we will see light. They will feel warm because the temperature is increasing, and the products will have less energy than the reactants. Okay, so I want you to think of and write down in your notebook some examples of exothermic reactions. So we can also describe what is happening in an exothermic reaction using an energy diagram, okay? Because the reactants in an exothermic reaction have more energy than the products. If I have my y-axis being the amount of energy, that means my reactants will be higher on the graph than my products. Okay, and then this, if we say progress of the reaction, so as time is going by, the energy is actually going to drop, and that energy needs to go somewhere. So that is the energy given off to the surroundings that makes the temperature of the surroundings increase. Okay, because all the energy that was in these reactants is now not in the product, so it has to have gone somewhere, and it goes out into our environment. As for endothermic reactions absorb energy from their surroundings, so they're going to suck the energy in, which means that the energy will be leaving their surroundings, so they will feel cold. Okay, this means that the products have more energy than the reactants because they've been pulling in energy from the surroundings to help boost that energy. These reactions are typically less common than exothermic reactions, but they do occur. If we look at the energy diagram now, we said that the energy in the reactants is lower than the energy of the products. So energy from the environment is going in so that the products have that energy from somewhere. Because remember, we can't make energy. We can just transfer it or transform it. So as the reaction occurs, the temperature of the surroundings will go down, and that's what we're measuring with our thermometer. Okay, because I can't measure the energy in the products directly. I don't have a probe to measure the energy in bonds. What I can do is measure the surroundings. Okay, so the solution, the solvent temperature that the solution is in. So in an exothermic reaction, energy is released into the surrounding as heat or light. So as a result, the temperature increases. Endothermic energy is pulled in from the surroundings, so the surroundings lose that energy and they drop in temperature. So I want you to have a go at classifying each of the following as exothermic or endothermic. Okay, so pause the video, write down what you think they are, and then come back to see the answers. Okay, so hopefully you paused the video, but we should have any combustion is exothermic. Okay, photosynthesis, it says it uses energy, so that means it's endothermic. Aerobic respiration releases energy, so that's going to be exothermic. And then sherbet cools your mouth, so that will be endothermic. Magnesium burns in oxygen. Any burning is exothermic because it's going to release light and heat. And then a chemical cold pack cools, so it's going to be endothermic. Okay, if it's using energy, endo, releasing energy, exo. Okay, so let's just have a quick look. I know this video has been going for a little while already at energy diagrams in a bit more detail. Okay, so one of the ways to help describe energy reactions is using an energy level diagram, and we need to be able to sketch these and explain what they're showing us. So an energy level diagram is essentially a graph that shows the change in energy of the system as the reaction progresses. So remember we said that the reactants had higher energy or lower energy than the products, and this determines if it was an exothermic or endothermic. Okay, so because we said bond breaking is always endothermic, this uphill bit here is showing us bond breaking, okay? And then the downhill bit is showing us bond making, okay? And in this case, we can see that the energy of the reactant starts out lower than the energy of the products. So the energy of the products is higher. This must be endothermic because I have increased the energy of the products, okay? So the energy absorbed is going to be equal to the difference between what the products and the reactants had. Same goes for an exothermic reaction. We've got bond breaking going up the hill, bond making going down the hill. This down section is bigger than the up section. So the difference between the line where my reactants are and the line where my products are is the energy that will be released into my surroundings, making the temperature increase. So an exothermic reaction, the energy is absorbed, and then we have a greater amount being released. In an endothermic reaction, energy is absorbed to break the bonds, but then we release less, so it is cooler. What I do want to point out quickly is the term delta H. This refers to a term we called enthalpy, which is a really funny sounding name. And if you're going to go on and do physics or chemistry later on in VCE, you'll hear this a lot more when you start doing thermophysics or thermochemistry. Okay, but essentially what this means, in order for me to figure out if the enthalpy is negative or positive, I need to look at the gradient of the line between the reactants and the products. So you remember with an exothermic reaction, we said the reactants had more energy than the products. So if I draw a line between the two of them, my gradient is negative. It's going to go down. So delta H is negative. And this is one of the things that we use to define an exothermic reaction. All exothermic reactions will have a negative delta H, whereas an endothermic, all endothermic reactions will have a positive gradient going from reactants to products on our energy level diagram, and delta H is positive. Okay, so this is like when we talked about motion, where we said in a vector quantity we had to have a size and a direction. The signs of delta H give us the direction of the energy change. Okay, so the direction of energy movement. And in this case, when delta H is negative, the energy is leaving the system and going into the surroundings. When delta H is positive, then the energy is coming into the system. It is gaining energy. Okay, so now you should be able to go through and make sure that you have completed all the work that you are set for endothermic and exothermic, and I'll see you in class.